Good morning. Today we will discuss about system. System is a device that generates output for a given input. Generally, system classified two type of system. The first one is continuous time system, it's called CT system, and it's called discrete time system. In continuous time system, a continuous system is one which operates on continuous time input signal and produces a continuous output signal. In discrete time system (DT system), a discrete system is one which operates on a discrete signal and produces a discrete output signal. So input is discrete, output is discrete. In continuous time system also, input is continuous, output also continuous. Okay. Next, types of system. Generally, we classify the types of system. The first one is static and dynamic system. Another is called linear and non-linear system. And third one, time invariant and invariant system. The fourth one, causal and non-causal system. Last one, stable and unstable system. We'll see one by one. What is static and dynamic systems? A system is called a static, or other name is called memoryless system if its output at any instant depends on its input at that instant, but not on the past and future values of the input. Otherwise, the system is called as dynamic or memory system. Okay, so the system is memoryless is called static system. The system having memory is called as dynamic system. I'll give some examples on system. Y of t equal to x of t minus t. Here, the output is depends on past values of input. This is x of t minus 2. So output depends on the past values of input. The system is called dynamic. Okay. One more example. Y of t equal to x squared of t. Here the output depends on the present input. Okay, not past. This is x square of t. It's called present. The system is called static system. Okay. Next. Here you see this one more example is given. This y of n equal to x of n plus 2. Here the output is depends on the future input. You see n plus 2. So it's the future input. This system is called also dynamic system. Okay. This is also a memory system. It's a dynamic system. Okay. Another classification is called as linear and non-linear system. A system that satisfies the superposition principle is called as linear system. Otherwise, it is called as non-linear system. What is superposition principle? It says that weighted sum of input signals be equal to the weighted sum of the output signal. So you see this weighted sum of input signals equal to weighted sum of the output signal. This is called superposition principle. That satisfies this principle, this system is called linear system. Otherwise, the system is called as non-linear system. So some examples given. Check whether the following system is linear or not. Y of t equal to e power x of t is given. You find out, apply superposition principle. What is superposition principle? You find out sum of this input signals. You find out this. So you find out this. So y1 of n t equal to, you substitute here e power x1 of t, y2 of x2. The output due to the weight of some input. So you find out this y of t equal to y3 of t equal to t a1 x1 of t b x2 of t. Okay. So this is nothing a y1 of t b y2 of t equal to, what about this value? So include the constant a1. I also using for b constant here. This is a b. So it's y1 of value e power x1 of t e power x2 of t. This is equation number 1. Okay. So next we'll go to find out y3 of t. So if we, this is not the output, this value is e power a power x1 of t. Okay. So into e power b x2 of t. So if you find out this output is, so the equation number 2 is called as equation number 2, the equation number 1. So 2 and 2 is not equal. This system is non-linear system. Okay, any doubt? Next. One more example is here in discrete approach. Similarly, you have to check, you consider the equation number 1. Here the equation number 2. So you have both are same, means this is a linear system. Okay. Next, another classification, time variant and time invariant system. If the time shifted output of the input signal results in corresponding time shifted in output signal, then the system is said to be time invariant system. Otherwise, the system is time variant system. Once again, repeat. If the system time shifted of the input signal result in corresponding time shifted in the output signal, then the system is said to be time invariant system. Otherwise, the system is called as time variant system. So this is a condition for time in y of t minus t1 equal to functions of x of t minus t1. This is a condition for checking time. Both are equal means time invariant. It's not equal. It's called time variant system. So check whether some system is given. So you will check this is a time invariant or variant. The system is you have to check here. So y of t is sin x of t. So the input is delayed, output delayed. So both are same. This system is time invariant system. So another classification for is called causal and non-causal system. So the causal is nothing but the output of system depends on the present and past input. So the system is depends on present past input. This is called causal system. It does not depend on future. The system is causal system. For example, the given y of n equal to x of n plus x of n minus 1 is the present and past. Okay, this is a causal system. So the output this system depends on future input. The system is called as non-causal system. Given example y of n equal to x of n, x of n minus 1, x of n plus. This is sets future. So any value will come future in that equation. This called system is called non-causal system. This way you check the system is causal and non-causal system. So one more example is given y of t equal to x of t minus 1. So this is like that we find out the causal and non-causal. Okay. Last one, the last class is called stable and unstable system. The system that produces a bounded output for bounded input is said to be a stable system. So you have to input is bounded, output is bounded, the system is stable system. So the input is bounded, output is unbounded, this is unstable. Okay. So what's the condition for stable? This is a bounded condition, the limit minus and plus infinity, magnitude of h of t is less than infinity. To satisfy this condition, the system is called stable. Okay, this is called analog approach, discrete approach. This is not satisfied, that question is unstable. Okay. Example, we check whether the following system is stable or unstable. So yeah, the given, so is given analog approach, you use this formula minus and plus infinity. H of t is less than infinity. Okay, yeah, use this and find out this value is bounded value. This system is stable. Like that you proceed. Okay.